central force is confined in a plane. Central force is confined in a plane. Central force is confined in a plane. The angular momentum of a particle, this is the y-axis, and this is the z-axis, and this is the x-axis. Its origin O, and this is a vector A, this is a vector B, and this is a resultant vector dr, and vector r, and vector r plus dr vector. This is origin point O. The angular momentum of a particle, the angular momentum of a particle, the angular momentum of a particle of mass m, moving with a velocity v, velocity p vector b, having a linear momentum, having a linear momentum, vector p equal to m vector v is given by vector j, moment of linear momentum, equal to vector r cross vector p equal to vector r cross m vector b, where r is the position vector, of the particle with respect to the center of the force laying at O. Vector r is the position vector of the particle with respect to the center of the force laying at O, the origin of the coordinate system. For a central force, the angular momentum j remains constant. When j remains constant, its magnitude as well as direction remains the same. If j is constant, its magnitude as well as direction remains constant, same. The direction of j is perpendicular to the plane containing to the vector r and v. Hence, the path of the particle under a central force must always lie in one plane. The containing vectors, vector r and vector b, if we take the direction of angular momentum j along the z-axis, the motion of the particle will take place in xy plane. Vector r and vector b will both lie in this plane. Hence, we conclude that motion under a central force is confined in a plane. Hence, we confined that motion that motion. We can find that motion under a central force, under a central force is confined in a plane, is confined in a plane, confined in a plane. Thus, the angular momentum of the Earth as it moves in its orbit around the Sun under central gravitational force remains constant in direction as well as in magnitude. Hence, the orbit lies in a plane containing the vector v, the velocity of the Earth, and the vector r represented its vector distance from the Sun. And we are writing about this, the angular momentum of the Earth. The angular momentum of the Earth. The angular momentum. The angular momentum of the Earth. The angular momentum of the Earth as it moves in its orbit round the Sun under a central gravitational force remains constant in direction as well as in magnitude. In direction as well as in magnitude. Hence the orbit lies in a plane containing the vector vector v, the velocity of the Earth, and the vector r, the velocity of the Earth, and the vector r representing its vector distance from the Sun. Its vector distance from the Sun. Okay, thank you.